Hello, I'm David. I'm the product manager of the SMEMA-Hermes adapter. However, today I'm not going to talk about the adapter. I'm going to talk about how you can integrate the software that we use on the adapter into your existing equipment. So, to disbelief, there are now 88 members of the Hermes standard, plus everyone who's implementing it who are not members, who are going off and implementing it. That's 88 plus teams around the world having to keep up with the developments of the Hermes standard. Now, I've made my feelings aware in other forums that there should have been an SDK, that is a software library that people can add to their existing software solutions to upgrade them to Hermes, so we're not all implementing it from fresh. The communication today is a PDF document, which means everyone else is going off and implementing it and reinventing the wheel in any gotcha situations along the way. Now, there is a C++ implementation on GitHub that is occasionally being updated, but in the true spirit of being a good software engineer and trying to help others, I thought it would be a good idea to just explain how the existing our software using MultiPlug and MultiPlug.Ext.Hermes can allow you to interact with Hermes on the kind of IP level, on the network level, and then interface with existing equipment to understand SMEMA states. So, first use case is simply communicating SMEMA states. So your machine knows SMEMA states and it just needs to communicate to the software. That software, the MultiPlug and the Hermes software, can run on a simple cheap device such as a Raspberry Pi, a Linux computer essentially, or any device that you have maybe already running on your machine. Maybe you've already got a Windows or Linux machine running behind the scenes on your equipment, and the MultiPlug and Hermes software can run alongside that quite nicely. So use cases, adding Hermes to the machine, of course, communicating with other MultiPlug.Extension-Hermes devices, or simply adding to or extracting board data records to the device that the software is running on. So you can be a PLC, for example, and you want to add some data, you can do so. And it's generally understanding the state of the software solution, I guess you'd call it, rather than the bigger solution, which may include your equipment. In the adapter situation, we interface via the SMEMA signals. But in this video, I just wanted to show you how to interface in different ways. So the first option is essentially the same option we use for the adapters, which is to interface via the SMEMA signals. You can remove our hardware and essentially create your own interfacing hardware to directly interface with in this scenario, the Raspberry Pi GPIO. So there's a cable between the GPIO and the PLC. If you're running a PLC, you might be, as I said, already running a larger solution based upon Windows or Linux, then you don't require that. The next solution, which is the solution I'm going to demonstrate today, is to use the MultiPlug events and to extend those rather than connecting to hardware interfaces, to connect to things like serial port or the network sockets. That can be on the physical machine, or it can be detached from the physical machine. The third option is to use the RESTful API. Now, going backwards, the RESTful API is documented on the software website, and in this scenario, this shows you how to toggle the SMEMA IO states using the RESTful API. So again, the software can be running on the same machine as your own software, and it can be simply talking to the local IP address 127.0.0.1, for example, and it can be updating the SMEMA state. That could be one solution. Obviously, it would require software, that software connection from your bit of software point of view, but it's a simple way of extending the SMEMA state. And of course, the first step of all this is actually understanding the SMEMA control. Getting actual data from, getting the board data and using that for your equipment is the next step. But this is just simply understanding SMEMA states and converting SMEMA into Hermes, and then connecting with to other machines, obviously, that are Hermes compatible. So RESTful API is documented there. I'm not going to go into it today. You can use, if you want to play around with this, you can use things like Postman, which is a way of mimicking the requests of the RESTful API and then changing the states. So direct connection, as I said to you, that's a bit more intense in a sense that you have to work out how to get a physical connection between your device, that being maybe a PLC, and the computer of choice in this situation, a Raspberry Pi. So the next one is multi-plug events. So I'm going to show you how to create a simple message between the serial port and the Hermes software. Remembering that in this scenario, let's say we've got a Raspberry Pi running MultiPlug, running the Hermes extension, and then we've got maybe a serial port hat that you can put on top of the Raspberry Pi, or maybe even a USB to serial port adapter, which then plugs directly into your PLC, for example. So that's what I'm going to do today. So let's go off to the serial port, enable the serial port. So if you're using an adapter, it will be displayed here, and you have connected it with the correct baud rate, etc. The only thing I want to set up is making sure it's reading to the carriage return. So that means every time a message comes in and the carriage return gets seen, it will then flag it up to the Hermes software. Now in Hermes, it's quite simple. You've got to make sure all the messages are unique, and you can come up with the messages. I'll show you how flexible it is. So upstream SMEMA, machine ready subscription. We want to subscribe to the serial port. Which is the only one there, that value, that. And here's the simple string values to say what is machine ready and what is not machine ready. So let's say machine ready, machine not ready. Okay, it can be any string value you like. So the messaging between the serial port and therefore your PLC or your bigger device can be whatever it wants to be. Want it latched, not ready, instant, like that. And then for the downstream, we do exactly the same. So we subscribe to the serial port. Serial port, we'll say good, ready, no ready. For that can be we're gonna share that between two actually. So bad ready. We'll subscribe to the serial port once again. I've seen that I've subscribed to the wrong event. So bad ready. I'm going to reuse that message, so no ready for that. I've just seen I've subscribed to the wrong event, so let's change that. Serial port, serial point adapter, save that. And then we see it's not connected at the moment, so let's do a deploy. And then they're all connected. So we just got to remember these values here: no ready, good ready, bad ready, and I've done the same there, haven't I? Okay, let's change that. Serial port adapter, deploy that. Right. So now, I've got my computer running this software, and now it's connected to a serial port of a PLC. So if I type in just machine ready, it's not displaying, but and press return. Oh, it's ready. So the board starts to move, and now machine not ready. It's gone back off, so the board's now moved to the machine. Let's just turn on local echo. I'm using putty to do this example. Now the command was good ready, and there you go. I think it was no ready, and that's it. So we've got the software running on a device, for example a Raspberry Pi, or it can be a PC or whatever device you've got running, and you can change the commands as you see fit, really, and that's essentially how to mimic the SMEMA states using a serial port rather than a physical hardware connection. Again, you can use the same process using the REST API. REST API is enabled in here. Machine ready RESTful API, you just need to enable it there. And then if you wanted to toggle that using the REST API, you would go SMEMA machine ready API, and that is the command you use as a post there, and that will also toggle the value. So that's a simple integration option. Now let's look at what all this costs, because this is the benefit, isn't it? You've got software already created and you want to quickly upgrade your machine. So benefits: little or no software development. I mean, there'll be no software development if you're using serial port. Little if you need to somehow create that RESTful API trigger from your software to this software. Software updates as needed, meaning every software update that we do to our adapter to do with the extension, you get. And then because you're basing upon your solution on a PC-like device, you can then connect to the CFX. You can then be CFX ready. And some board handling manufacturers have implemented the Hermes standard directly onto their PLCs, and it means they're running on devices with limited resources, and it means that software upgrades are very rare. And this solution abstracts or removes the control mechanism of the equipment to the data side of the solution, being the Hermes standard. And so any other data standards that come along, such as the CFX, can be supported. Let's look at the bill of materials. What does it all cost? Well, Raspberry Pi £42, MultiPlug software £20, the Hermes software license £55, and then you need a serial port to connect to your device. So in this situation we've used an adapter, but then as I said, there's hats you can buy for this Raspberry Pi, which might be more of a solid solution. It's up to you. So that's a total of £125, 143 euros, or $166. And of course there's volume licenses available. So I thought that would speed up and help the community to roll out Hermes quicker, and those are your options using MultiPlug and the Hermes extension. I hope that's useful. Please feel free to get in contact, and thank you for watching.